and Assalamualaikum. We are from Group 12. Today, we are going to talk about the instruments that are generally used for the determination of the various pollutants in marine environment. Okay, the next instrument is the Fourier transform infrared spectroscopy. It is also known as FTIR. Pyroelectric detector is used in this instrument as it has fast response time. FTIR spectroscopy is used to verify the origin of potential microplastic particles from synthetic polymers. Infrared spectroscopy is an active molecular vibration, hence it provides additional information on microplastic samples. The energy of the infrared radiation excites a specific vibration will be depending on the wavelengths. It will be absorbed to a certain amount which enable the measurement of characteristic infrared spectra. How does FTIR spectroscopy works? During the measurement, the infrared beam enters the interferometer and is directed at a beam splitter. The beam is then split and directed at the fixed and moving mirror respectively. The beam is recombined and causes interference. Then it is directed at the sample material. The spectral information of all wavelengths is acquired simultaneously, saving a lot of time. The FTIR spectroscopy allows us to identify microplastic down to 6 microns. It also can provide further information on physiochemical weathering of sample plastic particles by detecting the intensity of oxidation.
So, the next equipment is the algal bloom sensor. The algal bloom sensor is a non-contact equipment which is it can monitoring the concentration of chlorophyll A. This sensor uses chlorophyll's innate fluorescence to detect the growth of the blue-green algae and sends alert when the threshold reach. This equipment is a rugged equipment which had been installed around the world's environment. This equipment do not need some maintenance because it complete with the IP68 enclosure. The algal bloom sensor has optical sensor technologies which is it can avoid the marine biofouling or the algae from contaminating the sensor. This action will facilitate us from regular cleaning. This equipment has optics specific to excitation fluorescence of chlorophyll A, which is it can alert about the development of algae bloom by obtaining the concentration of chlorophyll A.
Hi, today I would like to talk about XRF instrument. XRF is an X-ray fluorescence spectrometer. An X-ray instrument used for routine, relatively non-destructive chemical analysis of rocks, mineral, sediments, and fluids. Now, we want to know about how XRF works. First, a solid, a liquid of the sample is irradiated with a high-energy X-ray from a control X-ray tube. An electron from one of inner orbital shell get kicked out from the shell. The atom regains stability by filling the vacancy left in the inner orbital shell with an electron for one of atom's higher energy orbital shells. The electron drops to the lower energy states by releasing a fluorescence X-ray. The energy of this X-ray is equal to the specific difference in energy between two quantum states of the electron. The measurement of this energy is the basic of XRF analysis. That's all about How the HRF work? Now we move to the fundamental principle of HRF. HRF is based on the principle that individual atoms, when excited by an external energy source, emit X-ray photons of a characteristic energy or wavelength. By counting the number of photons of each energy emitted from a sample, the element present may be identified and quantitated. As we know, the HRF is an instrument that can detect pollutant. To be simplified, HRF can detect metal pollution. And others like identify alloy, detect trace elements, analyze precious metal, and so on. Before we move to the others member, and we can hear them explain about other instruments that can detect pollutant, I want to tell additional info, which is HRF have two main types of instrument, which is ED-HRF and WD-HRF. Bye-bye.
The instrument is GCFID. GC is routinely used in air monitoring to detect volatile organic compound or VOCs, which may arise from environmental pollutions, pesticides, and explosives. Gas chromatography is a technique used to separate, detect, and quantify small volatile compound in the gas phase without decomposition. In GC, liquid samples are vaporized and then carried by an inert gas through a long, thin column. Analytes are sprayed based on their chemical affinity with a coating on the inside of the column. The GC instrument has 5 essential components. First, an injection port is used to introduce the sample into the instrument. Next, a heating chamber vaporizes the sample and mixes it with an inert gas. The inert gas, such as helium, nitrogen, and argon, carries the vaporized sample through the system. Combined, the carrier gas and sample make up the mobile phase. Mobile phase that enter the heat column, separating the analytes as the following through. Lastly, a detector, flame ionization detector, records the gas as they exit from the column and send data to a computer for analysis. The most critical components of the instrument is the column. The column is a capillary with a stationary phase metric coating the inner walls. Analytes with low chemical affinity for the stationary phase move quickly through the column, while molecules with a high affinity are slowly as they absorb to the column wall. The detectors sit at the ends of the column and record gas as they elute. In a FID, analytes combust in a hydrogen-air flame as they exit the column. To detect these ions, 2 electrodes are used to provide a potential difference. The positive electrode is positioned near the nozzle where the flame is produced, while negative electrode is positioned above the flame. The current is measured by the electrometer amplifier into a proper voltage and will be displayed into our computer software. The final result is a chromatogram, which is a plot of FID signal versus time taken for analytes to pass through the column. The number of peak presence indicates how many components in the mixture. GC can be used to track and identify and detect almost all carbon-containing compounds. For example, we can see the pollution in the Kim River, which the pollutant is methane, ethyl benzene, limonene, toluene, and xylene. Most of them can be detected using GCFID.
Next is UV-based spectrophotometer. How does it work? A beam with a wavelength varying between 180 and 1100 nanometer passes through a solution in a cuvette. The sample in cuvette absorbs this UV or visible radiation. Different wavelength that been absorbed shows different particle exist in the sample. Fundamental principle. A beam of light from a visible and UV light source is separated into its component wavelength by a prism or diffraction grating. Each monochromatic beam or single wavelength in turn is split into equal intensity beams by a half-mirrored device. One beam, the sample beam, passes through a small transparent container cuvette containing a solution of compound. The other beam, the reference beam, passes through an identical cuvette containing only the solvent. The intensities of these light beams are measured by electronic detectors and contact. Type of pollutants that can be analyzed. Transition metal ions. All transition metals are highly toxic to life at low level. Some are also known as heavy metals such as cadmium and mercury.
And I will explain about this digital ion analyzer. This is the instrument to analyze the ion content in the sample. Okay, now we talk about this advantage. Firstly, this can monitor a particle in the sample simultaneously and continuously. So, it means if in the sample have 2, 3 or more the pollutant, it can detect all of them in once. So, every pollutant in the sample, they can calculate and measure continuously. So, then display measure data in graph and table. So, after the measure the pollutant, they display the data easily in graph. So, we can get the graph after they finish measure the pollutant. And by then, just record all analytical detail. So, the analytical detail like the date, time, type of sample, and also the location. Okay, we will go through the methodology. So, ion chromatology technique is measure the concentration of ionic species by separating them based on their interaction with the resin. Resin is the high viscosity measure of the organic compound. So, when the sample, the ionic concentration of the sample interact within the resin is produce the liquid. It's not liquid, it's something like liquid like. Then the special ions spread depend on their type and size. The sample solution will pass through the phasor chromatographic column where the ions are absorbed by the column constituent, which is the part by part. Then as ionic extraction liquid, known as L1, run through the column, the absorbed ion begins spread from the column. This is the one column and the another column. So the first one, the ion is absorbed to the column, and the second one, the ion is absorbed from the column back to the liquid. So by the resin time, the concentration ionic can be determined. And this application to analyze the drinking water for the pollution, determine the chemical content in food and determine the chemical in water. It's not just about the seawater, but also the river and pond. The water source.